Welcome to The Explainer. Today, we're going to pull back the curtain on one of the world's most popular programming languages. Now, we all know Python for its clean, object-oriented design, right? But is that really the whole story, or does it have a secret identity hiding just beneath the surface? When we think about programming paradigms, we usually like to put languages into these neat little boxes. You've got your purely object-oriented languages like Java over on one side, and then you have the classic functional languages like Lisp on the other. But Python? It doesn't really pick a side. Instead, it builds this amazing bridge, taking some of the best ideas from both worlds. And that is the big question we're tackling today. We're going to see how this blend of object-oriented structure and functional flexibility isn't some kind of compromise. It's actually Python's greatest superpower. Okay, let's dive right in. Here's our game plan. First, we're going to uncover this functional veneer that sits on top of Python's object-oriented core. Then, we'll check out how Python's whole approach to functions is different. After that, we'll get into the real power of treating functions like objects. And finally, we'll see the ultimate team-up in a feature you probably use every single day. All right, let's kick things off with a piece of code that is so common, you've probably typed it 1,000 times without even thinking about it.
At first glance, len of my list looks like a classic functional call, right? It's just a simple, standalone function, you pass some data into it, and it gives you a result back. Super clean, super direct. But what's really happening behind the scenes? Well, that's pure object-oriented magic.
The secret here is something we call dunder methods, and that's just short for double underscore. Think of these special methods as a secret handshake. They're what allow the objects you build to hook directly into Python's built-in functions and syntax, making your code feel incredibly natural. So here's where the trick is revealed. When you call that simple little len function, the Python interpreter immediately turns around and asks the mylist object, hey, you got a len method for me? It then calls that method directly on the object itself. That functional call is really just a super user-friendly disguise. And this isn't some one-off trick. This pattern is woven into the very fabric of Python. Just think about it. So many of these common built-in functions are really just elegant shortcuts to an underlying special method on an object. It's a beautiful blend of convenience on the outside and a powerful, consistent, object-oriented design on the inside. Now, this same kind of thinking applies to how we define our own functions. So how does Python deal with functions that need to handle different kinds of input, or maybe even a different number of inputs? In other languages like C++ or Java, if you want a function to work with different data types, you often have to write the same function over and over and over again. It's a thing called function overloading. Well, Python just says, nope, there's a better way. Because Python is dynamically typed, you can write one single flexible function that just adapts to whatever you give it. And to make all this happen, Python hands developers this amazing toolkit. With special syntax like the slash, the asterisk, args, and quirgs, you can design a function to handle pretty much anything. Positional-only arguments, keyword-only arguments, or even a totally random number of inputs. This is a huge deal, because that lets you build these incredibly adaptable tools without writing tons of repetitive code. Okay, this flexibility we've been talking about, it's actually a hint at something much, much deeper, a core concept that Python borrows directly from the functional programming playbook. This is where Python's functional identity really starts to shine. This is the incredible idea of functions as first-class citizens. What that really means is that a function isn't just a block of code that does something. It's a value. It's an object, just like a number or a string. You can stick it in a variable, you can put it in a list, and this is the most important part. You can pass it as an argument to another function. And that ability is what makes a super powerful pattern called a callback possible. It's like you're handing a to-do list to another function. You're saying, hey, when you're done or when something interesting happens, just run this code for me. It's absolutely fundamental for things like user interfaces, responding when someone clicks a button. And here's a perfect real-world example. Let's say you're downloading a massive file. The download logic itself shouldn't have to care about how you display a progress bar. So you just give it a simple reporter function as a callback. The downloader does its job, and every once in a while it calls your reporter function to say, hey, I'm at 50%. This is what we developers call a clean separation of concerns, which really just means your code is way easier to understand and fix later on. All right, it's time for the grand finale. This is where we see Python's object-oriented foundation and its functional elegance come together perfectly in a piece of syntax that is, frankly, one of its best features ever. Let me ask you this. When you're working with external stuff, like files, network connections, that kind of thing, what's one of the easiest, most common ways to introduce nasty bugs and resource leaks into your code? The answer is simple: forgetting to clean up after yourself. So look at this simple code. You open a file, you do some work, and then you close it. Easy. But uh-oh, what happens if an error blows up right there in the middle while you're working? The program crashes, and that file.close line, it never even runs. That file gets left hanging open, locking up a system resource. This is a classic bug. For years, the solution was this mess on the left, this try finally block. And yeah, it works, but man, is it ugly and hard to read. Then Python gave us this beautiful, simple, elegant solution on the right, the with statement. It's clean, it's clear, and it absolutely guarantees that the cleanup will happen no matter what. And here it is. The secret identity is out. So how does this incredibly simple syntax work its magic? Well, it's our old friends, the dunder methods, back again. Any object that wants to work with a with statement just needs to have two special methods: __enter to handle the setup, and __exit to handle the guaranteed teardown. It is the perfect team-up, a clean, functional-style syntax powered by a rock-solid, object-oriented protocol under the hood. So, at the end of the day, what we've discovered is that Python's true genius isn't about choosing one camp over the other. It's about being practical. It's about blending the organized structure of objects with the expressive flexibility of functions, so you always have the right tool for the job. So now that you know its secret identity, how are you going to use this full power? By understanding both sides of its personality, the functional style and the object-oriented engine, you can write clearer, stronger, and just more Pythonic code. The next time you type len or use a with statement, you'll know the secret that's at work. Thanks for joining us for this explainer.